right, so let's take a look at something a little bit more complicated. So our first question is, do we have something that follows the pattern that we are currently learning? So do I have something that I can rewrite in the form of a partial with respect to x and a partial with respect to y equals something, right? Some constant, something like that, depending upon what information we're given. Now, we are given an initial condition, so we can explore that one a little bit. So at this particular moment, it doesn't fit that form. So I'm going to have to do a little bit of algebraic manipulation to get it into the correct form so that I can even investigate the whole partial question. So let's see. If I multiply by y times 1 minus x squared to both sides, I get y 1 minus x squared dy. And then that lovely expression, xy squared minus cosine x sine x dx. Now, it's not quite in the right form yet because I need to put it on the same side. So that would be negative x squared, xy squared minus cosine x sine x dx plus y 1 minus sine squared, or 1 minus x squared dy equals 0. Okay, so that looks a little bit better. Negatives sometimes make me a little nervous, so I'm going to do a little, again, another clever algebra trick. So I'm going to distribute that x squared in, and that's going to give me cosine x sine x minus xy squared dx, and then y 1 minus x squared dy equals 0. Okay, so now I've got it in the form that I can now test to see if I can now figure out what m and n are, and then even test to see if it's still an equation that I can solve using this current method. So my m, and again, just a reminder, if there is some function out there, then this partial with respect to x would be cosine x sine x minus xy squared. And if there in fact is some f function that fits this pattern, then my n function would be y 1 minus x squared on that. Okay, so then I want to do the other direction partial. So I want to find the f of xy, which is the partial of m with respect to y. Cosine x sine x, that's all in terms of x, so that would be considered a constant. And so minus xy squared would just be negative 2xy. And then I want to do the same thing over here. So partial of n with respect to x, which would, so the y is treated as a constant, and 1 minus x squared, the one derivative 0, so minus x squared would be 2x times the y. So, yay, we now have something that fits in that form. Good. So let's go forward. All right, so again, we have a little bit of freedom as to which one we want to attack as far as integrate. Oh, sorry, I'm about to sneeze here. Okay, so which one, whether we want to look at the m function or the n function. I kind of scrolled those up there. No, I didn't. Okay. And I'm looking at that y, the partial with respect to y, so the n function, and I think that one looks a little bit easier. So f of x, y would be the integral of y 1 minus x squared dy. let's see. So 1 minus x squared would be considered a constant. And so that then would be y squared over 2 times 1 minus x squared plus some other function in terms of x. Okay. So then I want to figure out what that function in terms of x is. So I want to take the partial with respect to x here of the equation that I just had. So y squared over 2, let's see. So that's going to be treated as constant, 1 minus x squared. Bring down, so negative 2x divided by 2. So I should get something like negative xy squared plus h prime of x. Okay, and then I'm going to do a little bit of highlighting here. So that statement should be equivalent to this statement. So that should give me a clue as to what h prime of x looks like. So let's see if I got room here. I can scroll up a little tiny bit. All right, so we got negative x y squared plus h prime of x equals cosine x sine x minus x y squared. Okay, so what does that clearly tell us? That tells us that h prime of x is equal to cosine x sine x. All right, so I then want to integrate that. With respect to x. Okay. All right, so let's think back to our techniques here. That looks like a good u substitution to me. So let's say u equals cosine x. Then du would equal negative sine x dx. So we're missing a negative. So integral of cosine x and the negative sine x dx. And I can translate that into u du. So that would be u squared over 2. And then I can just substitute in my u. So that would be negative cosine squared x over 2. Okay, so let's put all of that together into our function. So we have, trying to see where I want to write this at. Okay, so we have y squared over 2, 1 minus x squared, minus 1/2 cosine squared x equals some constant. All right, and then we had an initial condition at the very beginning, which is y of 2 equals 0. So that means we can then go solve for that constant. So y of 0 equals 2. Sorry about that. Okay, so let's see if we can figure out what this constant is. So when x is 0, y is 2, so we got 2 squared over 2, 1 minus 0 squared, minus 1/2 cosine squared of 0 equals our constant. All right, so let's do a little simplifying then. be, 2 squared is 4 over 2, so I got a 2 here, minus cosine of 0. Oh, let me double check my math on this. Alright, so 2 minus a half equals our constant. So 2 minus a half is 3/2 equals our constant. And I see a lot of halves here, so I'm going to make a decision at the end here. So we have y over 2, 1 minus x squared minus 1/2 cosine squared x equals 3/2. And that's a perfectly fine equation. I just happen to see a bunch of 2's, so if I multiply everybody by 2, I end up with 1 minus x squared minus cosine squared x equals 3. So both of those are perfectly fine equations.